This is Elise here from Advanced Quantitative Reasoning, and this is the little tutorial that I have for Fallon's Bistro. It's called the All-American Breakfast Choices. So, if you look at this right here, you have these choices. You have 3 for eggs, 1, 2, 3. You also have 3 for meat, 1, 2, 3. We also have 3 types of bread. That'll give you 3 times 3, which is equal to 27. So there's a total of 27 combinations here. And you have to understand, these are really, really easy. Now, usually, right here, when you see a tree diagram, you're thinking, oh, this is for probability. It has to be probability. And yes, you're absolutely right. It is probability. But there's a few little changes. If you notice, instead of the customary 1/3, you have 0.42. That stands for 42%. That means 42% of people who walked into the restaurant and ordered the All-American Breakfast, I don't know if you can see it, All-American Breakfast, the American Breakfast, is only $3.99. Usually, 42% of these people that ordered this ordered fried eggs. Now, there's a difference between experimental probability and theoretical. The theoretical says this is 1/3. But this is the experimental. That means that they actually have some data. Like they got 100 people into the restaurant. 42 of them ordered fried eggs. So right here, this is where they got this. Same thing for the bacon, which 75%, yum, ordered bacon, and 10% ordered, sausage, and so on and so forth. So what we're using is their past data to go ahead and try to predict human behavior that will go ahead and order these particular items. Now remember, up and down, you're adding. From left to right, you're multiplying. So if I need to go ahead and find out anything specific, I need to find out, all right, what is the probability that somebody orders scrambled eggs, bacon or sausage, and then finally Italian toast. So this is very basic. This is very easy. This is not too tough to go ahead and do. All you need to do is look at a couple of things. So number 1, scrambled eggs. Well, that's 0.36. So that's equal to 0.36. And you're going to multiply that by, and it says bacon or sausage. So we take the bacon percentage and the sausage, and you're going to add them together. So 0.75 plus 0.10, as you can see, it's starting to form up, times the Italian toast, which is 0.60. And as you can see, we have all this. Really easy to do. I'm going to get out my calculator. Now, parentheses are important, or you just add them beforehand. So I could say this is 0.85, or I can do the math. So if you can see 0.36, whoa, that's the wrong one, 0.36 times parentheses 0.75 plus 0.10, stands for 10%, times 0.60. And that comes out to 0.836. Which, if I multiply this by 100, gives me 18.36%. And that's what we got right here for this particular one. Also, if I want to go ahead and do it the other way, let's see if that works. 0.36 times 0.85 times 0.6. You still get the same exact number, so you don't need to worry about that. One warning, if you do it with this method, make sure you keep your parentheses. If you don't have the parentheses, you're going to get something wrong. So watch. Let me go ahead and show you with this one. I'm going to remove the parentheses. Delete that. And delete this one. Enter. 0.33. Now what's going on here is that the calculator's computer doesn't understand that, hey, I want to do the addition before I do the multiplication. It does it by PEMDAS. Remember, multiplication comes before addition, so it's going to do the multiplication before it does the addition. Also, one more thing I want to bring up. If you don't care about an item, like if you want the probability of somebody ordering fried eggs and you don't care about the meat. And Italian toast, just like this. Remember, the one that should go in the middle becomes 1. Or you're multiplying by 100%. You're for sure going to get it no matter what. You're going to get some type of meat. So this would be 0.42 times 1 times 0.60. That gives me 0.42, whoops, 17, no. 42 times 1 times 0.60. So that's 0.252 or 25.2%. As you can see, it's pretty simple. You can go ahead and work these out. One more thing is the not. What is the probability you're not going to order, that someone won't order the fried eggs or Italian toast? So it works out kind of the same way, except you do one little step more. Since we have this in decimal, we're going to subtract this number from 100%. So it's like taking 0.42 times 1 times 0.60, and you go ahead and first do your multiplication. You subtract that from 100 or 1, and you get out a new number. So let's see. So that'd be 1 minus 0.252. So 1 minus 0.252. So that's 74.748. And so that means that that's 74.8%. And you're probably asking, well, this would work better with 100. Well, yeah, you probably would, but you know what? It's going to give you the same exact answer, except in percentages. So 25.2, okay, minus 25.2, 74.8, which is exactly what I got. All right, so you can see how this works. I want you to understand that a sample space is also every single one of these. This is the sample space. The number of choices within the sample space is 27, and also their ending probabilities are part of the sample space. So you just need to worry about that. Not much to go ahead and go on besides that. You should understand this. This is real easy stuff. See you guys.